Okay, for this topic, I'm going to assume that you know the graphs of sine, cosine, and tangent. So let me quickly draw them. Sine repeats every 2 pi. And the graph looks like that. This is y equals to sine of x. Cosine also repeats every 2 pi. And the graph goes like this. Y equals to cosine of x. And then y equals to tangent of x. This looks completely different. This actually has vertical asymptotes at pi over 2 and also negative pi over 2. The graph looks like this. And there's another pi here, and then 3 pi over 2. There's another one. And it just keeps repeating, and here it repeats as well. Oh, by the way, these also repeat as well. So we'll take that as common knowledge. And I want to talk about arctangent of x, also known as tangent inverse of x. Now let me first justify having such a function. So suppose this being a maritime college, let's think about the following situation. So you're like 10 miles from a port A, and you're managing the ship. You're the captain of the ship. And then you're at the bridge controlling the ship, and then suddenly you get some communication from port authority at A saying that there are just simply too many ships that day, and they advise you to divert your traffic to a nearby port, let's say port B, that's 7 miles north. You have to go that way. So you now have to turn your ship to another direction, right? So now the question is, what should this angle be? All right, so what you do is, so you say, you use tangent of theta because, see, you're given 7 and 10. Those two values are opposite and adjacent legs to this angle theta. See, this is at the opposite of this angle, and this is right adjacent to theta, right? So because tangent is, according to SOHCAHTOA, tangent is opposite of adjacent, tangent theta must be 7 over 10. Is that right? Yeah. But the problem is we can't use the tangent function because tangent function requires the input to be an angle and out comes the ratio. What we know is the ratio, and you're trying to find what the input was. Is that okay? Yeah. So let's think about that. What we need is an inverse function. What's an inverse function? Yeah?
It basically switches how it goes to input to output, from output to input.
Right. And there's my favorite way of explaining this, right? If you have functions are like machines, right? If you have a chicken and this machine turns that chicken into nuggets, right? Then what's the inverse function? It takes the chicken nuggets back into chickens, real life chickens, right? Yeah. So it takes input and output, switches it, right? So because of that, what you do is you use the inverse function, which takes this output as your input, and when you calculate this, out comes your angle. Now you can use this calculator. There's the tangent inverse function right over the tangent, so it's like shift or second or something. You do that, and I did this earlier, so I memorized the value. It's about 35 degrees. It's 34.99 something. So I invite you to try this. This is what you get. 34.99 degrees. something like this. So that tells the captain that, oh, we should now steer the ship 35 degrees towards the north, and then you can get to port B straight over. So this is all good. However, there's something strange going on here, because if you knew the graph of tangent, you know that this shouldn't have an inverse function, because it doesn't pass the horizontal line test. Why is it bad to fail the horizontal line test? It gives you multiple different values to give you the same output. So for example, we just figured out that tangent 35 degrees is 7/10, but because tangent is periodic with respect to 180 degrees, or every pi, if you add 180, you get 215 degrees, which also gives you 7/10. So I kind of explained this using the following story, right? If you, let's say, now you have the machine changing chickens to chicken nuggets, but let's say you have two types of chickens, like red chicken and the blue chicken. They're both produced into chicken nuggets. Now what's the problem when you try to make the inverse? You take a nugget, and the machine doesn't know whether to produce the red chicken or blue chicken. So there's no way to, I mean, of course, realistically, there's no such machine. But let's say if we could make real life chickens out of chicken nuggets, right? But even if we had that technology, it would still be impossible, because you wouldn't know whether to produce the blue chicken or the red chicken. Right? So that's the problem. If you have two different things giving you the same output, it makes it impossible to develop the inverse function. So what's really going on is the following thing. The tangent inverse prohibits this. In other words, what it does is it takes the tangent graph and it restricts the function to be only over -pi/2 to pi/2, so that once it's restricted, now it passes the horizontal line test, right? The horizontal lines only pass through the graph once. And let me write that statement. Okay, so tangent inverse of x is the inverse function of tangent of x whose domain is restricted to -pi/2 to pi/2. So that's something that you should know. And because of that, some people don't like the word tangent inverse, because tangent function as itself, it doesn't have an inverse. It only has an inverse after you restrict it to a smaller domain. And that's why some people prefer to use the word arctangent over tangent inverse. And we end up using both. Yes?
Does that restriction apply to cosine?
So for the cosine and sine, we'll have to figure out different restrictions. That we'll eventually do that. Okay? But for now, let's try to ask and answer the following question. So question, what is the domain and range of tangent inverse of x? Well, here's how you think. The original function has domain what? -pi/2 to pi/2. That's your domain, right? Now, once you have that restriction, look at the graph and see what the range is. Range is the y values, which is the height. How high does it go? Infinity. How low does it go? -infinity. So what's the range? -infinity to +infinity, right? That's the range.
It's the inverse.
And therefore, when you take the inverse, domain and range switches. So that means tangent inverse takes the domain as -infinity to infinity. It means that any real numbers any real number can be an input to the tangent inverse. On the other hand, the range, the output of the tangent inverse will give you only angles between negative 90 degrees to positive 90 degrees. See, pi over 2 radians is 90 degrees because pi is 180 degrees, right? 180 divided by 2 is 90 degrees. So that gives you any value between negative 90 degrees to positive 90 degrees. Okay, so we did this one carefully, but now let's move on to defining the sine inverse. So again, the second part, arc sine and sine inverse. They mean exactly the same thing. It's just a matter of preference. But because literature is divided in some people like using this one and some people this one, you have to know both. Okay, so let's go to the sine function. Again, it's not going to pass the horizontal line test, right? If you draw a horizontal line here, it's going to pass it twice here, but then also passes in other places, so that's not good.
Does it also, whenever it's inverse though, does it always restrict them?
You have to restrict in order to have the inverse, okay? Or else you can't define the inverse because of the red chicken, blue chicken. Yeah. Okay, so please look at the graph and think about where we should restrict the graph so that it has an inverse function, or where so that it passes the horizontal line test. Yes?
From 0 to 2 pi?
Oh
no, wait.
Yeah, so if you restrict from 0 to pi, it still fails the horizontal line test, right? Yes.
Pi over 2 to 3 pi over 2?
Okay, so that's a valid one. That's possible. If you take this much, it certainly passes the horizontal line test. Except that for practical purposes, many times you try to find an angle inside the right triangle, and therefore the angles that the inverse function should spit out should be angles between 0 to 90 degrees. So those are preferred over the others. So while your answer is right, it's not the preferred one. Yes?
Would you do negative pi over 2 to pi over 2?
That is correct. So what you do is you go from negative pi over 2 to pi over 2. And if you restrict the graph like this, then it passes the horizontal line test. And therefore, we can say that sine inverse of x is the inverse of sine of x restricted to the domain as from negative pi over 2 to pi over 2. Okay, so allow me to use some symbols. I'm using this bar to say restricted. Okay, so it's like if you put something beyond outside this domain, you don't allow it. Okay, so if you restrict your original machine to only take in values like that, then of course you can define an inverse function, right? Okay, so once again, let's try to figure out the range of this thing. What is the range? And for that, you have to look at the graph. How high does it go?
1.
1. How low does it go?
-1.
Negative 1. So the range is?
1, -1.
Negative 1 to 1. You always start from the smaller number, okay? All right, so now we can ask and answer a question. What is the domain and range of sine inverse of x?
It's the same, it's just flipped.
It's flipped, right? So domain would be negative 1 to 1. And the range would be negative pi over 2 to pi over 2. Now if you compare the tangent inverse with the sine inverse, they both have range from negative pi over 2 to pi over 2. However, there's a slight difference here. I'm using parentheses, which are also called open brackets. Open brackets means that the actual values are not included. So tangent inverse can never spit out exactly 90 degrees. It only gives you something slightly less than 90 degrees, or from something slightly above negative 90 degrees. It can't reach negative 90 degrees. It can't reach positive 90 degrees. On the other hand, this can. So in fact, if you plug in sine inverse of 1, it will give you 90 degrees. Okay? So that's what you can do. Another main difference is that for sine inverse, you can only plug in values between negative 1 and 1. So a note here that you should try if you have a calculator. By the way, if you have a calculator, please try to actively do this, okay? If you do sine inverse of 2, so for my calculator, I first have to put 2 and then shift sine inverse. That's how I do it. And if I do that, I get this as the output. Some of the more fancier calculators will say domain error.
Yeah, no, mine said
Domain error?
domain error.
What do I have to do?
So-
Can't show undefined results.
Right, right. So this doesn't exist. Why? Why does that happen? Because this 2 is outside this domain. If you plug in anything that's less than 1 and bigger than negative 1, it'll do fine. It'll give you something. But once you get something above 1, it will hate it. Because it can't give you an answer. Right?
I pulled 1 in there, he gave me 90.
Yeah, good. Yeah.
That's good.
All right, and for the arc cosine, it's the same story. Arc cosine of x, aka cosine inverse of x, and there will be the cosine inverse of x is the inverse function of cosine x restricted to somewhere. Okay, so let's look at the cosine. Where should I restrict this?
What are we looking at here?
Cosine. Where should I restrict?
0 to pi?
0 to pi, exactly. If you restrict from 0 to pi, then this much will pass the horizontal line test, so everything will be fine. So this domain will be 0 to pi, and therefore the range would still be negative 1 and 1. So in this case, if I ask the same question, what is the domain and range of cosine inverse of x, what's the domain? These two flips, so what's the domain? No, no.
-1.
Negative 1 to 1. Yeah. What was the domain becomes the range. What was the range becomes the domain, right? Because if you take the inverse function, input and output switches, which means domain and range switches. Okay. And then range would be 0 to pi. So that kind of explains everything. Let's do a quick example of the cosine one. So suppose you're given a right triangle where this is 5 and this is 4. So it's like 3, 4, 5 triangle, okay? And you want to know what this angle is. So what do? You say cosine of theta is 4 over 5 because cosine is adjacent over hypotenuse, SOHCAHTOA, right? So what is theta? It's given by cosine inverse of 4/5. And you have to use a calculator. So some of these calculators you have to write this first. So 4 divided by 5,
36.
and then you take the cosine inverse, and that gives you 36.87 degrees, or about 37 degrees. Okay?